Welcome to the first Engineers Newsletter live broadcast of 2009. Today we'll be covering the major changes recently released in US GBC's LEED 2009 documents. I'm Jeannie Harshaw from Trane's Applications Engineering Department, and I'll be your host for today's program. Through our association with the American Institute of Architects, credit towards continuing education can be earned for viewing today's broadcast. So be sure to provide your member number to your local host before leaving today's session. In several states, AIA certification can also be applied to engineers' continuing education requirements. Some states may require members to complete a short test, so please check your state's rules to see if this might be applicable. LEED 2009 Green Building Certification Program was introduced this month after 8 years of user feedback. This update incorporates highly anticipated regional credits, extra points that have been identified as priorities within a project's given environmental zone. LEED has also undergone reweighting of credits, changing allocation of points among credits to reflect climate change and energy efficiency as urgent priorities. This is one of the most significant changes to the rating system and will increase the importance of green building as a means of contributing immediate and measurable solutions toward energy independence, climate change mitigation, and other global priorities. Our goal today is to cover the major changes in LEED 2009, the impact they may have on HVAC practitioners, and new capabilities and modeling tools used to achieve optimized energy credits. We've made a minor change to our program format this year. Rather than host a live question and answer session, we'll provide answers to your emailed or faxed in questions online within 3 weeks after this scheduled program. So please fax in your questions during the broadcast to the number on your screen or email enl@trane.com. Be sure to provide your email address so we can respond directly to you. To cover this information today, we have 3 presenters. A new face to the ENLs is Scott Hintz. Scott is a marketing engineer in Trane's CDS support group. In addition to his support role as CDS marketing engineer, Scott is responsible for customer training of CDS software and project management of Trane's Option Analyzer software. He's currently a consultant to the Energy Cost Budget Subcommittee of SSPC 90.1 and is a LEED accredited professional. Joining Scott is Mick Schwedler. Mick is chair of SSPC 90.1, which was responsible for writing ASHRAE 90.1 2007. He has also contributed to the ASHRAE Green Guide and is a member of the LEED Energy and Atmospheric Technical Advisory Group, or TAG. Mick's primary role is helping designers properly apply Trane products and systems. We're also very fortunate to have Chris Shea join us today. Chris is also a LEED accredited professional whose current responsibility is to understand all commercial industry related green and environmental initiatives such as EPA Energy Star program, US GBC's LEED program, and a host of others. We have a lot of information to cover. So Chris, would you get us started with the major changes in LEED 2009?
Thanks, Jeannie. Before reviewing the green building progress and LEED 2009, I would like to quickly remind the audience why we are on the road together. The building facts on the slide can help us make some sense. In the United States, buildings use 39% of primary energy, 72% of electricity consumption, 14% of potable water, and account for 1 million tons of construction debris and municipal waste. The building industry also accounts for nearly 15% of gross domestic product. Globally, it consumes 40% of raw materials, roughly 3 billion tons annually. Since buildings are a necessity and takes up resources, building performance improvement is definitely an important focal point for building owners, architects, engineers, contractors, and even financial institutions. The green building rating system provides a holistic method to work on improving the building performance. U.S. Green Building Council, or USGBC, is the leading organization in transforming the traditional building practices. With 15 years under its belt, USGBC continues to move the market with excitement and gain support from the government, profit and nonprofit organizations, and the building industry. 4 unique programs stand out when talking about USGBC. First, LEED Green Building Rating System engaged many volunteers who have devoted countless hours to develop and advance. Second, LEED Building Certification transitioned from paper to online submission of LEED documentation and continues to improve the process. Third, over 77,000 individuals passed the LEED Accredited Professional Exam. And last, over 28,000 people attended the annual Greenbuild Conference and Expo in Boston last November. All of these activities are coming together because not only scientists provided a wake-up call on climate change, but also because of you. People wanted to do the right thing for both environment and their business. USGBC provides the tools and the forum for people to contribute and do the right thing for themselves and their community. We will quickly go through the progress in this area, and we will spend the majority of our time in LEED 2009 and the changes related to existing rating systems. USGBC's LEED product continued their journey in transforming the building industry. Most of the people in the building industry know USGBC, the LEED Green Building Rating System, and even how they worked. Although this is a volunteer standard, administered by USGBC, many government agencies, federal, state, and local government, have mandated the new building seek LEED certification. For example, in 2003, the General Services Administration, or GSA, the nation's largest landlord, required that all capital buildings projects earn LEED certification with a target of LEED Silver. By 2008, GSA began requiring all LEED construction achieve LEED Silver. Since the rollout of LEED version 2.0 in 2000, LEED products continue to expand and improve. Many products have been introduced since then, notably LEED for existing building and LEED for commercial interior in 2004, LEED for core and shell in 2005, and more. Multiple products with varying timeline have added the confusion and often make it difficult to follow. These different products are intended to make sure that the entire building life cycle is covered under LEED rating systems. As depicted in the slide, many products used in different applications are intended for the design and construction phase, and LEED for existing building is used for building operation and maintenance throughout the building lifetime. By now, most of you are familiar with the 4 levels of certification for LEED buildings, namely Certified, Silver, Gold, and Platinum ratings. LEED 2009 continues this tradition. The display of this plaque continues to signify the environmental stewardship of the organization. Here is the progress of LEED registered and certified projects. As Rob Watson indicated in his recent Green Building Impact Report, the Green Building Impact is both encouraging and cautionary. LEED buildings are making a major impact in reducing the overall environmental footprint on an individual basis. However, for LEED to contribute in a significant way in reducing the overall environmental footprint, there is more progress that needs to be made. He also mentioned that LEED certified projects represent more than 6% of new construction, and there has been an astronomical ramp up in the past year for new project registration, with new construction sector penetrating, approaching a whopping 40%. On average, it takes approximately 2 years from registration to certification, with an attrition rate of 25% to 30%. This report provides a good assessment on LEED progress. Another piece of information came from FMI, management consulting and investment banking provider to the construction industry. Its 2008 U.S. Market Construction Overview explains that how the green building market is expanding at such a fast pace. Factors such as unprecedented level of government initiatives, heightened residential demands, and sustainable material improvements are expediting the growth of the green buildings. On the membership and LEED accredited professional front, as you can see, USGBC continues to attract more companies to join and more individuals to become accredited in recent years. For example, Trane has over 450 LEED accredited professionals currently, leading and setting a great example for our industry. The Greenville annual USGBC conference continues to bring in a large number of attendees. In his opening remark at Greenville 2008, Rick Fedrizzi, USGBC President, CEO, and founding chairman, stressed that the green revolution is in the making, and it is critical work for buildings and communities. Rick said, our value has to evolve so that the future is more important than the now. We must force people to look beyond first cost to its total triple bottom line return on investment. The business case is there. For pennies upfront, the payback is in dollars. And more importantly, it improves people's life. He elaborated further saying, green economy can ignite the market through innovation, provide high-paying green jobs that cannot be exported, help homeowners and small business save money, and change how the building industry measures value. In this financial turmoil, Rick's message has encouraged and helped the undecided owner to look into real financial incentives in constructing, maintaining, and operating green buildings. Many free videos clips from Greenville Conference are available on greenville365.org website. You may want to experience the level of top-notch speakers and excitement yourself. Now, let's move on to the changes. LEED version 3, commonly referred to as LEED V3 initiative, combines three components into one. USGBC used LEED V3 to respond to the requests of advancement, speed, capacity, and certification. Included in LEED V3 are LEED 2009, the LEED certification process, and LEED Online V3. LEED 2009 incorporates new construction, core and shell, commercial interior, existing buildings, operation and maintenance, and schools into bookshelf approach, synchronizing the development and deployment cycle. More of this concept will be shown in the later slides. Since we will highlight the changes between LEED NC 2.2 and NC 2009, the best way to show the differences is to put them side by side. In the following slides, we will compare the major differences in each category. First, we will take a look at all of the prerequisites. The highlighted area are the numbers of prerequisites in each category. Notice that a new water efficiency prerequisite has been added to emphasize the importance of the water. For LEED 2009, the same rule applies that all prerequisites must be met in order to qualify for any certification level. And next, the point distribution. The highlighted area are the point structure in each category. You can clearly see difference between the two versions. The weighting of each category is changed. For example, energy and atmosphere points are up to 35% from 25%, while indoor environmental quality are down to 15% from 22%, without considering the new regional bonus points and innovation and design process points. The total points now equal 100 points from 5 main categories. This makes it easier for people to calculate the number of points required to achieve a certain level of certification. The rule is 40, 50, 60, and 80% for certified, silver, gold, and platinum. Since the total number is 100, the percentage cutoff is the same as the points cutoff. That is 40, 50, 60, and 80 points for certified silver, gold, and platinum. Innovation and design process and regional bonus points make up 10 extra points that are not included in the base number of points. This can be a significant driver in LEED projects. Let's take a closer look at it. In these two graphics using 100% scale, it is easier to see the points weighting in sustainable sites, water efficiency, and energy and atmosphere have increased, while material and resources and indoor environmental quality has decreased. Let's focus our attention on the lower half graphics for NC 2009. 5 innovation points and 1 LEED AP points can be as high as 6% of the total point distribution. For regional bonus points, there are 4 points available. For example, the regional chapter can dedicate 1 regional bonus point for exemplary water efficiency performance because of the importance of the water in the southern region of the United States. Projects that originally seek the exemplary water efficiency performance under innovation and design point now have an open point for other innovation ideas. The selection of these extra points can overlay anywhere in this point structure, make it more flexible for the designer and user to pick where they want to focus their attention, i.e. make dollar cents in their life cycle return on investment. And Mick, that's all I have for now. What's next?
Well, Chris, we're going to start to get into some of the specifics. Chris showed us the LEED 2009 product differences. Perhaps the first question people ask is, why are they changing at all? From a high-level perspective, 2008 was a year in which the LEED's program's high momentum was becoming realized. The number of LEED-certified projects increased to over 2,000. LEED-registered projects exceeded 16,000, and LEED-accredited professionals by the end of 2008 topped 69,000. With such growth, it may have seemed like a time to ride the wave. However, USGBC members and those outside of USGBC also noted that there were some issues that had to be dealt with. Up until now, there were LEED products for schools, for new construction, for retail, and others. As these new LEED products were honed, they became more dissimilar to satisfy a specific project type. While warranted in many cases, it began to cause confusion among practitioners. With rating systems that were similar but not identical, the situation was ripe for errors to inadvertently occur. The accredited professional distinction was also becoming less understandable. A person who had taken the test years ago was still accredited, but did the test taken correspond to their present work? Some critics of LEED also stated that perhaps the focus of rating systems had moved away from the core of leadership in energy and environmental design, and it was time to relook at the systems. USGBC wanted to ensure that these issues were addressed and expended a significant amount of volunteer time, staff effort, money, and work to address them. A major undertaking during this process was to look across the LEED products and make sure they were similar. According to USGBC, the resultant prerequisite credit structure is a consolidation, alignment, and updating of all existing LEED rating systems into their, quote, most effective common denominator. In response to the marketplace, USGBC also committed to a 2-year development cycle. The next changes following LEED 2009 will be LEED 2011. This provides stability to the marketplace, but still allows USGBC to respond rapidly when necessary. Credit weighting was also changed. As stated on the USGBC site, the term weightings, as it is used herein, refers to the process of redistributing the available points in LEED, so that a given credit's point value can more accurately reflect its potential to either mitigate the negative or promote positive environmental impacts of a building. In a few minutes, we'll look at this at a high level, then also dig into some specifics. We'll see that this was a very involved process. Finally, USGBC wanted to address the fact that there are credits that should be different due to regional conditions. The easiest one to understand is water usage. In arid climates like Mexico or the U.S. Southwest, water usage is absolutely critical to enable any level of sustainability. LEED 2009 allows issues like this to be addressed on a regional basis. Rather than having separate and different rating systems dependent on project type, USGBC worked to ensure that the same thresholds achieve the same credits in all LEED project types. Scott will cover the credit distribution in a minute. For example, retail had its own rating systems prior to LEED 2009. It's now covered in the LEED for new construction and major renovation document. However, there are some differences in how credits can be achieved for retail. Another example, schools were deemed different enough to warrant a separate rating system, but the USGBC worked hard to use the same requirements consistently. One further example, LEED for healthcare, which is out for public review. During its development, the healthcare group wanted to change the levels to achieve specific credits. Prior to LEED 2009, this was sometimes done. So now, USGBC uses a bookshelf concept where they use the same books for all the LEED products. The books are the LEED credits. Due to harmonization, the requirements for credits are the same for all LEED project types. USGBC is working hard on finishing the reference guides so that these differences are understandable and obvious. That briefly is the work on harmonization. Scott, please take us through how the distribution of credits was performed and discuss its impact.
Thanks, Mick. Let's talk about the LEED 2009 credit weighting. The LEED 2009 scorecards are the result of some important development initiatives undertaken by USGBC. The changing allocation of points among LEED credits was done to reflect energy efficiency and climate change as urgent priorities. The re-weighting that was performed resulted in the redistribution of the available points in LEED so that a given credit's point value more accurately reflects its potential impact on the environment. Okay, the first step was taken in re-weighting LEED involved deciding which environmental impacts LEED should be addressing. The 13 impact categories were derived from the EPA's Tracy program, the tool for the reduction and assessment of chemical and other environmental impacts. The initial weighting applied to each category was based on input from the National Institute of Standards and Technology, NIST. For the greenhouse gas emissions category, building energy consumption was based on a combination of CBEX, Energy Star, and EPA eGrid data. The LEED Steering Committee and USGBC staff also provided specific requirements that guide the weighting system. Credits must total 100 points, be positive integers, and be static independent values. Core building functions were the basis for organizing all LEED credits into activity groups. Each activity group represents a group of credits that are associated with the issue. For example, building systems includes credits that, of course, relate to building energy use. When determining the impact categories and activity groups, the LEED Steering Committee used a basic weighting equation. The equation brings together information on building impacts, building functions, otherwise known as the previously established activity groups, and the association with the activity group, a binary relationship indicating whether or not a credit contributes to reducing an impact. This approach was implemented in a spreadsheet called LEED 3.0 Credit Weighting Tool. Again, the LEED Credit Weighting Tool was created for use by the LEED Steering Committee for the purposes of weighting credits. This will not be used by HVAC practitioners. The new scorecards for LEED 2009 are the result of the data analysis by the credit weighting tool we just discussed. The final weights were expressed as a percentage, and each credit point was fed into a typical LEED scorecard to arrive at a subtotal of 100 points. As Chris previously pointed out, a 100-point rating system resulted in the following thresholds: certified, silver, gold, or platinum requiring 40, 50, 60, and 80 points respectively. Let's look at the effects to the LEED scorecards from the re-weighting process. The re-weighting process produced scorecards that look different from the existing scorecards. Here we show the differences in category points for LEED NC 2009 as compared to NC 2.2. As stated earlier, this was mainly due to the LEED Steering Committee and USGBC's goal to place heavy emphasis on credits that reduce a building's carbon footprint. As we can see here, the impact of the top three categories, sustainable sites, water efficiency, and engineering atmosphere, has significantly increased, comprising over 70% of the 100 base points. This is compared with LEED NC 2.2, where these three categories accounted for just over half the base point total. Originally, the innovation and design credits were a part of the total base points. However, now they are considered extra. Along with the regional priority credits, a team now has 10 points outside of the 100 base points to aid in attaining the desired certification. There will be 5 bonus points for innovation and design, 4 bonus points for regional priority, and 1 point for LEED accredited professional as a member of the project team. What does this mean for the HVAC practitioner? Well, now more than ever, it is quite obvious to say that reduced energy consumption and a reduced carbon footprint will drive and be at the forefront of all LEED building designs and projects. In a few minutes, we'll discuss in greater detail the energy and atmosphere, indoor environmental quality, and water efficiency categories and credits. Before we do that, let's discuss the new credit category of regionalization or regional priority. Previously, LEED had been applied uniformly across the U.S., and point values were equally achievable of credits across various regions. USGBC proposed and now has introduced regional bonus credits to increase the value of pursuing credits that address environmental areas of concern in a project's region. This enhances the flexibility of LEED and provides a more effective method to address the need for regional adaptation. The possible exportation of LEED to other countries is greatly enhanced with the regional adaptation gained from the regionalization of credits. This slide from the LEED V3 launch presentation at Greenbelt last year shows the 79 USGBC groups nationwide organized into 9 regions. The groups in each region will select 6 credits in each existing rating system as regional credits. These regional credits will be similar to exemplary performance points of the previous LEED rating system. Currently, the selection of the regional bonus credits is underway. As an example, this slide from Greenbelt shows the 6 credits that the Upper Northeast region has chosen for bonus regional credits for LEED commercial interiors. Out of these 6 credits, a project team could earn up to 4 bonus points. Input from the USGBC's Energy and Atmosphere Technical Advisory Group is such that EA credits should not be available for regional bonus credits. According to Mick, a member of the EA TAG, Earth appears to have only one atmosphere. I wasn't able to attend the GBI session at Greenbelt that discussed the changes to certification testing and how this will affect current LEED APs. However, Mick, you were able to. Could you fill us in on this?
Sure can, Scott. At the 2008 Green Build Convention, Peter Templeton and Beth Holst of the Green Building Certification Institute gave a seminar addressing the changes for both professional accreditation and LEED project certification. GBCI will be responsible for both under LEED 2009. Please refer to gbci.org for the latest information. The first thing that was addressed is the credentialing of present or legacy LEED professionals. They made it very clear that the present LEED accredited professionals, or APs, do not, I repeat, do not need to retake the exam. People may still register for the present LEED AP examinations until March 31st, 2009. Present LEED APs will need to agree to the Code of Ethics and will remain on the active LEED AP database until June 2011, even if they do nothing else. But if you opt into this between June 1st and June 30th, 2009, the initial fee is waived. And to remain active on the list beyond that time, a total of 30 hours of professional training, with 6 hours being LEED specific, must be completed by June of 2011. Now, moving forward, there will be 3 tiers with biennial credentialing requirements, changing by tier. We'll look at those shortly. No matter the tier, everyone must sign the disciplinary policy and agree to credentialing maintenance. To maintain credentials, many of the same professional development hours that are accepted for professional engineers or architect licenses may be used. In addition, some credit may also be available for presentations, for example, at conferences like Greenbuild. These specifics have not been shared yet. Now let's look at the 3 tiers. The first is LEED Green Associate, which requires having involvement in support of LEED projects, being employed in the sustainable field or engaged in green education, and submitting to an application audit. An examination covering basic or core information across all LEED products must be passed. Finally, every 2 years, 15 hours of education must be completed, with 3 of them being LEED-specific. Following achievement of Tier 1 LEED Green Associate, a practitioner can move on to Tier 2. Tier 2, the LEED accredited professional, represents in-depth knowledge in a particular field or LEED rating system. There are 3 commercial specializations as of now: design and construction, operations and maintenance, and commercial interiors. Other specializations include residential design and construction and neighborhood development. In addition to the requirements of a Green Associate, one must demonstrate experience on a LEED project and document work on a specific LEED project within the last 3 years. This can be done through verification through LEED Online or employer attestation. In addition, an examination on the specialty chosen must be passed. For example, someone could pass the LEED for Homes examination and become a LEED AP with a specialization in residential design and construction. Once accredited, every 2 years, 30 hours of professional development with at least 6 LEED-specific must be accrued. According to the credentialing program, the 3rd tier is LEED AP Fellow. To quote from the GBCI website, LEED AP Fellows enter an elite class of leading professionals who are distinguished by their years of experience. This is established by a peer review of their project portfolio. Okay, so when does all this happen? Here are some highlights on the timing, which is scheduled to be finished by September 1st. February, LEED Green Associate Tier 1 beta test will be ready. March, LEED for Homes beta test. May, the core exam for Tier 1 goes live. In June, credentialing maintenance requirements will be finalized and LEED AP for Homes will be available. August, LEED AP exams for commercial interiors and building design and construction will be available. In addition to accreditation, project certification has also been shifted to GBCI. In the past, projects were reviewed by USGBC with the support of independently contracted reviewers. In mid-2008, it was announced that 10 certification organizations would be responsible for performing project reviews. Beginning in January 2009, GBCI began administering this process and overseeing the certification process. In the announcement, it was stated that not only was this third-party certification important, but, quote, it allows USGBC to stick to the knitting of advancing the technical and scientific basis of LEED. So GBCI concentrates on certification, and USGBC focuses on the LEED products. Chris, could you get us started with what all this does to the HVAC practitioner?
Sure, I will do my best. Before jumping into HVAC-related prerequisites, you may want to know that sustainable site and material and resources prerequisites are virtually the same as NC version 2.2. First, let's look at all the prerequisites and their respective changes. The major differences are on EA Prerequisite 2, Minimum Energy Performance, EQ Prerequisite 1, Minimum Indoor Air Quality Performance, and WE Prerequisite 1, Water Use Reduction. We will discuss them individually in the following slides. The rest of all the prerequisites are basically the same as NC version 2.2 with only a couple of wording changes for search clarification. In LEED NC 2009, for minimum energy performance, there are 3 options to comply with: 1 performance compliance path and 2 prescriptive compliance paths. We will examine each option as compared to NC 2.2. As of June 26, 2007, EA Credit 1 optimized energy performance require at least 2 points for NC 2.2. The first option of the prerequisite for NC 2.2 is to meet both the mandatory provision and prescriptive requirement of 90.1/2004 and simulate the building under Appendix G Building Performance Rating Method, PRM. The proposed building energy performance will need to be at least 14% better to meet this prerequisite. For NC 2009, the threshold is 10% better than, and the corresponding standard is ASHRAE 90.1/2007 without the prescriptive requirement. Since modeling is required, not all of the prescriptive requirements need to be met, i.e. the energy consumption can be traded between spaces. Also, projects in California are permitted to use Title 24, 2005, Part 6 in place of ASHRAE 90.1/2007 for this option. Option 2 of this prerequisite is the prescriptive compliance path for both. NC 2009 adds 3 more advanced energy design guides for use in different applications. Option 3 is also a prescriptive compliance path. Following the June 2007 ruling, this option was eliminated for NC 2.2. For NC 2009, the Option 3 prescriptive compliance path is to comply with Advanced Buildings Core Performance Guide developed by New Buildings Institute. Limited building types, sizes, and sections of the guide apply. We will cover this core performance guide and provide an example in a few minutes. This concludes the major changes in minimum energy performance. Let's move on to EQ Prerequisite 1, Minimum Indoor Air Quality Performance. The main difference of the minimum indoor air quality performance prerequisite is the reference to ASHRAE 2007 standard instead of 2004. The 2007 version of the standard has been modified significantly. The designer will need to review the proper way to design according to 62.1/2007. Scott will cover this area in more detail later. The last prerequisite with major changes is Water Efficiency 1. US GBC listened to popular demand on water savings. Now, LEED adds a prerequisite for water efficiency. This prerequisite actually comes from the original Water Efficiency Credit 3.1, 20% water use reduction. The baseline is expanded from the original Energy Policy Act of 1992 and adds the Energy Policy Act of 1995 and the Uniform Plumbing Code or International Plumbing Code of 2006. The water reduction will need to be 20% better than the baseline. Besides the high efficiency fixtures for water savings, water collected from the cooling coil condensate can help contribute to this prerequisite. This concludes our review on major prerequisite changes. Before we go through the HVAC-related credits, I will quickly go through credit changes in sustainable sites and materials and resources. In sustainable sites, many credit points and language stays the same as in 2009. For those points that stay the same, their impact has been reduced. Bicycle storage and change in facilities are a good example of the reduced significance. On the other hand, the importance of development density, community connection, and public transportation access has significantly increased. With a total of 11 points, they become very hard for LEED projects to ignore. It can be expected that future green buildings will help promote better public transportation systems and community connection. In addition, low-emitting and fuel-efficient vehicles also gain more weight and provide better explanation on how to gain points. From credit 5.1 to 8, all of the points stay the same. The major language changes occurred in heat island effect for non-roof and light pollution reduction. For example, to reduce heat island effect in the non-roof area, it provides more methods for both options. Option 1, 50% shade for site hardscape, or option 2, 50% of parking space under cover. In both options, solar panels are mentioned that can be used to provide shade and generate energy at the same time. Let's move on to material and resources credits. In material and resources, most of the credits retain the same number of points. The point structure is changed in building reuse. It has 3 points versus 2 points in 2.2 version. Besides adding 55% building reuse for the first point, the credit language does not change. On the construction waste management credit, the potential technologies and strategies added language that construction debris that is processed into a recycled content commodity can be added into construction waste calculation. Credits listed here regarding to recycled content and regional materials did not change at all. Just as a reminder, mechanical and electrical components are not counted in the calculation for recycled content and regional materials. You probably will also be interested in paying attention to the development of certified wood that is under major development. Until it is passed by the membership vote, certified wood will continue to use NC 2.2 language. That's all for the non-HVAC related credits. Mick, could you please take us through the changes in HVAC related credits?
Sure can, Chris. But before we get to the LEED HVAC credits, let's cover ASHRAE 90.1 2007 changes as they significantly impact the LEED prerequisite. ASHRAE 90.1 2007 is ASHRAE 90.1 2004 plus all approved addenda up to its publication date. Each addendum must be moved forward for public review and publication. If there are comments during the public review process, the 90.1 committee contacts commenters to understand their issues, votes on responses, and if changes are made, sends the addendum for another public review. SSPC 90.1's goal is to reach consensus. Following the committee's work, the addendum must receive approval at other levels of ASHRAE, including the Board of Directors. The ASHRAE Board of Directors approved 44 addenda for inclusion in 90.1 2007. We'll cover a few of the more significant changes today, so you have some idea of the differences between 90.1 2004 and 90.1 2007. Significant changes were made to the envelope section of 90.1. Both the opaque elements, walls, roofs, floors, etc., and fenestration or glass requirements changed and generally become more stringent. This means that heat conduction loads and solar loads should be reduced. In the mechanical section, equipment efficiency increases occurred for boilers, three-phased air-cooled air conditioners and heat pumps, and air-cooled air conditioners and heat pumps. The SSPC attempted to estimate the savings based on implementation of each addendum. The estimates shown on the slide are taken from the forwards of each addendum. While a fairly small change in the text of the standard, the reference to ASHRAE Standard 62.1, ventilation for acceptable indoor air quality, changed from the 1999 version to the 2004 version. So addenda that changed Standard 62.1 are now used to define the minimum requirements of 90.1 also. As discussed on previous broadcasts, the addenda changed ventilation requirements, and for each zone the requirement is now based on the sum of a per person and per square foot requirement. Please refer to the Engineers Newsletter in the bibliography for more information. On our last E&L broadcast, we spent quite a bit of time covering demand-controlled ventilation. The threshold for which DCV is required for a space was reduced and now applies if the space is more than 500 square feet and the design occupancy is greater than 40 people per 1,000 square feet. In the controls section of 90.1, an exception that used to exclude hotel and motel guest rooms from the off-hour controller requirements was deleted. The fan power limitation in Standard 90.1/2007 is now based on either nameplate horsepower or system brake horsepower with the limit shown on the slide. This was done in response to feedback from design engineers. In addition, the standard also defines specific pressure drops that are allowed for a given device in the system. For example, MERV 13 filters are allowed 0.9 inches of pressure drop. This addendum has been well received by practitioners. There have been requirements for technology to reduce part load fan energy use in the standard for quite some time. The threshold for variable speed drives, or another technology that gives similar performance, was reduced from 15 horsepower to 10. In the lighting area, the retail display lighting requirements were changed to give more flexibility to system designers. As I said, these are just some of the 44 addenda that are included in 90.1/2007. But they give you some flavor of the major areas to examine as you move to developing buildings that are 10% better than 90.1/2007 as the prerequisite for LEED 2009. Now shown here is the breakdown of credits in the energy and atmosphere section. As Scott told us, the total is now 100 rather than 69. Due to the redistribution, the EA section now covers 35% of the available credit points, compared to just under 25% in the previous LEED for new construction, version 2.2. In every EA area, the percentage available increased. Optimizing energy performance allows projects to achieve 19% of possible credit points, and on-site renewables, 7%. These two areas alone comprise a higher percentage than the entire EA section used to. So one of the takeaways is there's a greater focus on energy in LEED 2009. In order to achieve these credits, there was restructuring, but no changes to enhanced commissioning or enhanced refrigerant management. Green power credit requirements had a clarifying note added. It states that the purchase of green power is based on the quantity of energy consumed, not the cost. Now, let's look at how the other credits may be obtained and what the changes are. Significant changes took place to energy performance, on-site renewable energy, and measurement and verification. All these changes deal with energy directly. Let's look at EA Credit 1, Optimize Energy Performance. To make it simple to achieve EAC1 points on small buildings, there are two prescriptive paths that did not require computer modeling. The Energy and Atmosphere Technical Advisory Group, or TAG, created language that allows a few points to be obtained on small buildings by following a prescriptive path. As we'll see in a minute, many more credit points are available through the performance path. The first path is to follow all the recommendations in the ASHRAE Advanced Energy Design Guides. One credit point can be obtained for offices, small retail, small warehouses, or K-12 schools. The Advanced Energy Design Guides are available at no charge from ASHRAE at the link shown on the slide. Thanks to ASHRAE and its president at the time, Kent Peterson, for making this happen. All the Advanced Energy Design Guides set recommendations for the envelope, lighting, HVAC, and service water heating systems for the specific building type. Okay, I have to self-disclose here that I might be a bit biased. I serve as an advisor to the ASHRAE AEDG Steering Committee, and I'm a member of the US GBCEA TAG. While the TAG's decision was to allow one prescriptive point by implementing all the recommendations in the AEDG, there's another option that you may want to consider. And I'll use the K-12 schools guide as an example. In its analysis, the K-12 schools AEDG was compared with ASHRAE 90.1/2004 and has the savings shown on the screen. Now these are compared to 90.1 2004, but the LEED 2009 comparison is with 90.1 2007. So the design team could specify a building based on the AEDG recommendations, then model that building as their proposed design. In many cases, the modeled savings may give significantly more than the single credit point allowed by following this prescriptive path. Modeling adds more work, but may be very beneficial in achieving the LEED certification level being sought. The second prescriptive option is based on a different document. The New Buildings Institute has a publication titled The Advanced Buildings Core Performance Guide that describes requirements that gain up to 3 points via a prescriptive path. Offices, schools, public assembly, and retail less than 100,000 square feet can be used under this option. There is a cost to obtaining the guide, and the link is given on the slide. To achieve 1 point, all the requirements in sections 1 and 2 must be implemented. A summary of the areas covered in sections 1 and 2 of the Core Performance Guide are shown on the slide. As you can see, there's a lot covered, and there's quite a bit of detail. We'll look at just a few examples of the requirements to see how they differ from 90.1 2007. Let's examine acceptance testing, lighting, and some equipment efficiencies. In the Core Performance Guide, there are requirements for documentation, as there are in ASHRAE 90.1 2007 in the completion requirements section. By the way, you may want to see if you're following the ASHRAE requirements, since they're required by EA Prerequisite 2. In addition to these, the Core Performance Guide requires operator training, including a formal walkthrough and training session to give building operations team hands-on experience and the chance to ask questions. This is an important requirement because the operators need to know how the building was intended to operate in order to run it efficiently. In Table 2.8.1 of the Core Performance Guide, the lighting power densities allowed are the same as 90.1 2007 for many building types. However, there's an important note that explains that in the Core Performance Guide, these power densities include video display terminals, decorative lighting, and display lighting. So the actual installed lighting power for people will need to be lower than the 90.1 2007 allowances. Here are two examples. Family dining is allowed 1.6 watts per square foot in both 90.1 2007 and the Core Performance Guide. But in the CPG, any decorative lighting, such as sconces, are included in the lighting power allowance. For retail, 90.1 allows 1.5 watts per square foot plus lighting to highlight merchandise. The CPG only allows 1.3, and that includes display lighting. Therefore, in many cases, the lighting power for general lighting of the space must be lower in the Core Performance Guide than 90.1 2007. Mechanical equipment efficiencies are also addressed. Here are a few examples of the efficiencies required. Perhaps standard efficiency units won't meet these levels, but many high efficiency pieces of equipment can be used to satisfy these prescriptive requirements. Obviously, there are also many more requirements in Section 1 and 2. Now, in addition to the single credit point, an additional point may be earned by employing 3 of the enhanced performance strategies. Up to 2 additional points may be earned. A few of the strategies are shown on the slide. So the Core Performance Guide could be used to attain up to 3 points in a prescriptive manner. These 2 prescriptive options give the project team the opportunity to achieve 1 to 3 points on smaller buildings, and no modeling is required. However, there are up to 19 points available if modeling is performed. So many project teams opt to model using Appendix G from ASHRAE 90.1 2007. Remember that the prerequisite is now 10% less energy cost compared to ASHRAE 90.1 2007 for new construction, and 6% less for existing building renovations. In EA Credit 1, Optimizing Energy, we can accrue points. For new construction, at 12% energy cost reduction, you achieve 1 point. For a renovation, 8% reduction allows 1 point to be achieved. Each additional 2% of energy cost savings accrues another credit point. Up to a maximum of 19 points can be achieved. Needless to say, there's significant emphasis on optimizing the energy within a project. Scott will help us examine the ways these points can be achieved in a few minutes. But there's also increased emphasis on renewable energy, covered by EA Credit 2. The available points from on-site renewable energy increased to a maximum of 7. 1 point for the first 1%, plus 1 point for each additional 2% as shown here. Those who implement on-site renewable energy usually attempt to reduce the project energy consumption in EA Credit 1 first. That way the same size renewable system becomes a greater percentage of the project's energy cost. This helps to make on-site renewable energy systems more cost-effective. Only one change was made to EA Credit 5, measurement and verification, but it's pretty significant. In the older version, a point was given for an M&V plan, but if there were discrepancies between the measured and the expected data, there were no requirements for changes to be made. The hopes were that the building owners would undertake plans to decrease their energy costs to the expected values and reap the benefits. However, some projects may have used the credit to simply get a point, rather than as a way to keep the building operating efficiently. This led to inclusion of requiring a process for corrective action to ensure energy savings are realized if measured results show that expected energy savings are not being achieved. So, in the Energy and Atmosphere section, there's increased emphasis on efficiency within the building and project, on-site renewable energy, and ensuring the project is operating as intended. With that said, 35% of LEED points are now covered in the EA section, and there is significant reward for project teams that use integrated approaches to reduce energy use and bring into play or increase on-site renewables. As always, we encourage people not to just look for points, but find ways to reduce the energy and environmental impacts of their projects. That's the EA section. How about the indoor air quality section, Scott?
Certainly, Mick. As Chris stated earlier, EQ Prerequisite 1, Minimum IAQ Performance, now references the 2007 edition of ASHRAE Standard 62.1. The purpose of Standard 62.1 is to specify minimum ventilation rates and other measures intended to provide indoor air quality that is acceptable to human occupants and minimize adverse health effects. As with Standard 90.1, Standard 62.1 is also updated on a regular basis using ASHRAE's continuous maintenance procedures. The 2007 edition is the latest edition of Standard 62 and combines 62.1 2004 and the 8 approved and published addenda to the 2004 edition. The 2007 edition incorporates addendas A through H. We'll cover a few of the more significant changes today so that you can have a better idea of the differences between 62.1 2004 and 62.1 2007. We'll discuss in further addendums B, G, and H. Addendum B corrects inconsistencies in tables 5.2, 6.1, and 6.4 and provides additional information for several occupancy categories. Table 5.2, Other Space Types, was deleted in its entirety. Employee locker rooms, kitchenettes, and private toilet bath space types were moved from the previous Other Space Types table to Table 6.4, Minimum Exhaust Rates, as occupancy categories. Addendum B modifies Table 6.4 by designating air classifications for auto repair rooms, arena, and science lab classrooms, which is renamed Educational Science Laboratories. A classification for science laboratories was added to the minimum ventilation breathing zone rate table, along with ventilation rates now being provided for spaces that were previously classified as other space types. Now, Addendum G in brief requires space classification based on expected presence of environmental tobacco smoke, ETS, separation of ETS and ETS-free areas, and cautionary signage for ETS areas. As defined, ETS spaces are those where smoking occurs or those that are not separated from smoking areas. This separation is achieved through a combination of pressurization and air tightness, as well as through limitations on air transfer and recirculation. Now lastly, Addendum H. What that did was delete tables E2 and E3 from Normative Appendix E, which provided ventilation requirements for residences and vehicles. It also adds requirements for residential spaces into the ventilation rate table 6.1. The ventilation rates for residential spaces differ from those included in ASHRAE Standard 62.2, 2004, because that standard assumes that some ventilation will be provided through infiltration, and it requires operable windows to provide extra ventilation when needed. Standard 62.1, 2004 rates are independent of infiltration and operable windows, which are not always applicable in high-rise construction. So the area-based rates are increased significantly relative to the rates in Standard 62.2, 2004. As Mick showed us, the effects of credit reweighting on the EA section impact in the EQ section also occurred, but not in the same sense. Shown here is the breakdown of credits for the indoor environmental quality section. As previously discussed, the new rating system total is 100 points rather than 69. Since no redistribution of the EQ section was done, we can see that this section now covers only 15% of the available credit points, compared with just under 22% in the previous LEED for new construction version 2.2. In each EQ credit, the percentage available decreased, which is the result of USGBC's focus for LEED 2009, again on energy efficiency and climate change as urgent priorities. So to restate the takeaway that Mick just mentioned, there is a greater focus on energy in LEED 2009. As we just showed, no redistribution of credit points were performed in the EQ section. However, requirements linked to ASHRAE Standard 62.1 in Credit 1, Outdoor Air Delivery Monitoring, and Credit 2, Increased Ventilation, now must adhere to the 2007 edition of 62.1. All right, next let's talk about the significant changes to the water efficiency credits. We can see the credit reweighting has also affected the water efficiency category. The overall category point total has doubled from 5 to 10 points. Both credits 1.1 and 1.2 deal with water efficient landscaping, where credit 1.1 is reduced water consumption for landscaping by 50% compared to a baseline, and 1.2 is no potable water use for irrigation or landscaping. Credit 2 addresses innovative wastewater technologies. All three of these credits doubled in value from 1 to 2 points. Credit 3 deals with total water use reduction again compared to a baseline. As Chris discussed, the original water efficiency credit 3.1, reduced total water consumption by 20%, is now the prerequisite for water efficiency. The water use reduction credit also doubled its total point value, along with increasing the required reduction thresholds and adding the 40% reduction threshold as a point to be awarded. Previously, the 40% reduction threshold was an exemplary performance credit available through innovation and design. The water use reduction credit is similar to EA Credit 1 in that greater reduction in water consumption increases available credit points. So in other words, reducing water consumption by more than 40% compared to a baseline will result in satisfying the 30% and 35% thresholds and a credit point total of 4 points. The thresholds have increased, however, the basic requirements for water efficiency credit 3 are still the same. Employ strategies that in aggregate use less water than the water use baseline calculated for the building, not including irrigation, and after meeting the Energy Policy Act of 1995 fixture performance requirements. The applicable fixtures are water closets, urinals, lavatory faucets, showers, and kitchen sinks. Mick, what would you expect some of the responses to all these changes to be?
The largest change in credit points weightings is with respect to energy. We've watched prices peak in the past year, then come back down, but not many people expect those prices to stay down for the 30 to 50-year life of their building. So there's significant focus on energy. Also, we're beginning to see more project teams consider recovering cooling coil condensate for other uses. While such reclamation won't satisfy all site water usage, cost-effective systems are being designed, installed, and operated, and they reduce the amount of water that must be purchased. In addition, many firms have developed general charts they use to determine ways to achieve various levels of certification for their LEED projects. Given the changes, it's a good time to revisit those charts and determine what adjustments should be made to help design, construct, and operate sustainable buildings. Okay, back to the energy issue. In most cases, achieving credit points will be done using an energy model. As most of you know, the Trane Air Conditioning and Economics, or TRACE, simulation tool can be used to model projects. Scott will take some time to talk about modeling. As always, he'll try to keep it as non-commercial as possible, but we'll discuss some misconceptions, some often seen errors, and even some new program capabilities available. Take it away, Scott.
Absolutely, Megan. Now that we've discussed the major changes for LEED 2009 and HVAC practitioners, let's discuss some capabilities and features of modeling for EA Credit 1 by use of a whole building energy simulation software. To determine the building proposed performance, the energy modeler creates a design building energy simulation model using DOE 2, such as eQuest for Visual DOE, Trane's Trace 700, Energy Plus, Carrier HAP, or another hourly load and energy modeling software tool. The requirements for a whole building simulation program are detailed in Appendix G of 90.1. We'll use Trane's Trace 700 building analysis software as an example to discuss some of the requirements and capabilities of modeling per LEED 2009 and ASHRAE 90.1 2007, Appendix G. You'll see most of these features and capabilities in other software too. Trace meets all of the stated criteria. Next, let's discuss some of the previously existing LEED capabilities that you may not be aware of. Today's building energy modeling software tools have the capability to model more than just HVAC energy consumption. Following Compliance Option 1 of Energy and Atmosphere Credit 1 requires a whole building simulation model. However, other LEED credits can be modeled too. The blue categories and the possible points in blue indicate the credits that can be modeled. Previously under LEED NC 2.2, the program could only help a design team gain up to 16 total points. As we can see here, the total possible points now under LEED 2009 has more than doubled when modeling with building simulation software. Next, we'll discuss some LEED modeling capabilities, including those capabilities outside of modeling for EA Credit 1 that most practitioners may not be aware of. For example, the calculation of cooling coil condensate recovery can help show reduced potable water consumption for the water efficient landscaping credits and the water use reduction credit. As required by Appendix G, a full year 8,760 hour analysis must be performed. In order to do this, the building must be modeled using what is called a full year weather file that has conditions for each hour of the year. From sources such as DOE 2's webpage, full year weather files of the type TMY, TMY2, TMY3, and others can be imported into the program's weather library. The file will be used by a new weather location that the user creates. Lastly, the program is set to run every hour of each day of the year. When modeling the baseline alternative per Appendix G, all equipment must comply prescriptively with Section 6.5 of 90.1. To aid in this, the Trane CDS department has created an import for the Trace equipment libraries. The ASHRAE 90.1 equipment library was created in response to confusion when users attempted to model various cooling equipment. The library import assists with answering questions regarding part load efficiency, package unitary, heat rejection, and more. In addition, it provides a step-by-step guide to help users understand how it works. The intention of the library is simply to help users start the modeling process. This can greatly decrease the time needed to set up and model the required baseline equipment, along with, of course, greatly enhancing the model's accuracy. It also provides an understanding of how to effectively input values into the program. The values used in the library were derived from certain assumptions, so some adjustments will need to be made for various applications. There are also two automatic features built into the program. So let's discuss them. System fan power calculation and baseline building rotation, both per Appendix G. The automatic system fan power calculation allows for automatic fan resizing. The fans will automatically be sized to follow the mentioned Appendix G requirements. In Calculate and View Results, if the user has chosen base alternative for the performance rating method, Trace will automatically determine the maximum fan energy when apply ECB PRM rules to fan sizing is checked in Change Energy Parameters. The baseline building performance shall be generated by simulating the building with its actual orientation and then rotating the entire building 90, 180, and 270 degrees, then averaging those results. Okay, let's discuss two output reports formatted specifically for LEED. The baseline energy use at each orientation is then captured and displayed on the Performance Rating Details report. The average energy use from all four orientations is then calculated and displayed on the Energy Cost Budget PRM Summary Report and compared to the proposed design alternative that the user has modeled. Both reports are formatted to make entry to online LEED templates easier and more straightforward. Now, let's look at modeling daylighting in the program. Daylighting systems can significantly reduce both lighting consumption and cooling energy consumption by reducing the electric lighting heat gain in the building. Daylighting definitions reduce the total lighting consumption and lighting load to a space, which of course can help achieve an increasing levels of energy reduction per EA Credit 1. Now, the program's daylighting algorithm is identical to that used by DO2, except, of course, for the user interface. A daylighting definition is created through the Actions menu. A credit point can also be rewarded when a specific level of daylighting is achieved. One credit point can be awarded per the daylight credit in LEED when following option 2, Daylight Simulation Model. Here we can see what the daylight illumination requirements are to achieve the daylighting credit. When users create daylighting definitions, the program generates a special report showing the foot candles of daylight present in the spaces with daylighting controls. As we can see here, the report outputs the daylight illuminance at the user-defined reference point. To further reduce energy costs as required to obtain EA Credit 1 points, thermal energy storage may be employed to balance energy demand between daytime and nighttime. Thermal energy storage can refer to a number of technologies that store energy in a thermal reservoir for later reuse. The thermal reservoir may be maintained at a temperature above or below than that of the ambient environment. Thermal energy storage combined with a lower supply air temperature may be a great way to help EA Credit 1 points. The principal applications for thermal storage are the production and use of ice, chilled water, or an ice water solution. Many utilities offer negotiable incentives for thermal storage. Contact your local utility representative to maximize the potential economic benefits. The next E&L scheduled for May 13th is Ice Storage System Design and Application. During this E&L, the team will discuss design of an ice storage system. For a more in-depth look at ice storage for LEED building design, check out Engineers Newsletter Volume 36-3. If you'd like to get a copy today, ask your local coordinator or visit the Trane website.
Hey, Scott, there's a lot of focus on energy, and that is a main point of LEED 2009. However, with the change to the water efficiency prerequisite, the water efficiency credits, the cost of water in some areas, and the fact that some of the regional credits may be used to address water usage, our applications engineering group has been getting more calls on things like cooling tower water usage and condensate recovery. What are you seeing on the modeling front?
Well, Mick, on the modeling front, in order to aid in calculation of total water consumption for the water efficiency credit, the program can calculate cooling tower water usage and cooling coil condensate recovery. Monthly consumption totals are displayed per 1,000 gallons and are totaled for a yearly consumption. Peak water demand is also calculated as 1,000 gallons per hour. The makeup water flow is calculated by entering the cost of water evaporated by the cooling tower in the heat rejection library. So for example, if the heat rejection equipment evaporates 3.5 gallons per ton hour, enter 3.5 as the value and gallons per ton hour as the units. However, if to be calculated is selected, the value of the makeup water is ignored. Instead, the program uses a cooling tower water usage algorithm, which is based upon cooling tower entering and leaving water temperatures, water flow rates, outside air wet bulb, and the assumed rates of 3% drift and a concentration of 5. We briefly discussed 2 reasons for water usage in heat rejection equipment. However, a third reason for water consumption is blowdown, as defined by the Marley Cooling Tower of Fundamentals. This calculation method is hour by hour and better accounts for the actual makeup water needs. The water of evaporation exits the tower in a pure vapor state, leaving behind its burden of total dissolved solids, TDS, to concentrate in the recirculating mass of water, jeopardizing not only the cooling tower, but the heat exchanger and all other water circuit-related components as well. The proper method for controlling TDS concentrations is called blowdown, where a portion of the circulating water flow is continuously wasted and replenished with relatively pure makeup water. In the 3.2 gallons per ton hour of heat rejection used by the program's standard heat rejection equipment, a concentration of about 2.5 was assumed. This is relatively clean water. If a user wants to change the concentrations for local conditions, the following chart of blowdown as a percentage of cooling tower GPM at a 10-degree range should be used. Next, let's point out some recently enhanced capabilities. Per Appendix G, baseline systems 1, 5, and 7 must reset their hot water supply temperatures based on outside air dry bulb. Per the graphic you see there, the reset schedule must be fixed to 180 degrees at 20 degrees outside air dry bulb and below, and to 150 degrees at 50 degrees outside air dry bulb and above. The hot water supply temp must then be ramped linearly between 180 and 150 at outside temperatures of 20 degrees and 50 degrees. All hot water heating equipment in the previously discussed 90.1 minimally compliant equipment library have now been set up to do the hot water reset schedule per Appendix G. 2 separate unloading curves, one for the outside air reset and one for the hot water reset, work in conjunction with the entered values for hot water leaving temperature and hot water delta T, which is used to determine the hot water return temperature. Okay, now, let's talk about supply air temperature reset. Per Appendix G, the baseline supply air temperature for cooling must be reset higher by 5 degrees under the minimum cooling load conditions. In trace, supply air temperature can be reset based on outside air or space conditions, as well as limit the amount of reset allowed. There are a number of different reset strategies that can also be modeled. Whether it's humidity control for either indoor air quality standards or for the preservation of perishable items, hot gas reheat for dehumidification is available for unitary cooling equipment, including air-cooled unitary, water-cooled unitary, and water source heat pumps. This feature assumes that the associated airside system has a reheat coil located downstream of the cooling coil for dehumidification reheat purposes. As a heat rejection device, it cycles between the normal heat rejection condenser and a heat rejection setup that feeds to a dehumidification coil. During the hot gas reheat cycle, there is ambient relief due to the fact that the refrigerant is being cooled much lower than ambient conditions, and therefore the equipment should run more efficiently. The maximum amount of hot gas reheat available is equal to the heat transferred from the air to the evaporator load plus the actual compressor heat of compression. So as discussed previously, prerequisite 1, minimum IAQ performance for the indoor environmental quality credits, requires that at a minimum, mechanical ventilation systems shall be designed using the ventilation rate procedure of Standard 62.1. A new ASHRAE Standard 62.1 report has been created in order to view detailed components of the 62.1 calculations that are used to determine outdoor air requirements. This new report can also be used to aid in attaining credit 2, increased ventilation, which requires 30% greater outdoor air ventilation rates as compared to the minimum of Standard 62.1 2007. If you've recently attended a Green Build conference or ASHRAE summer or winter meetings, you have noticed an increase in the discussion of alternative systems and design. In response to interest in alternative system designs, 3 new system categories have been added to the program. They are underfloor air distribution, chilled beams, and displacement ventilation. True and actual performance can now be verified as opposed to using potentially inaccurate hand calculations, which in some cases did require the use of the exceptional calculation method of Standard 90.1. The underfloor air distribution category has 6 new system types. The displacement ventilation category has 5 new system types. And lastly, the chilled beam category has 2 new system types. Until now, no major whole building energy simulation software has had the direct ability nor available user interface to model these system types. Something also to keep in mind for the 3 system types we just discussed is their potential need for humidity control. Engineers and designers still need to keep a, quote, building physics approach in mind and realize that air temperature alone is not the complete goal of a building interior climate control system. 2 Engineers Newsletters are available to help answer these questions. Advances in Desiccant-Based Dehumidification, Volume 34-4, and Better Part Load Dehumidification, It's Not a Pipe Dream, Volume 33-2. To further point out, Class 3 desiccant systems and their resulting dehumidification can be modeled in the program as an exhaust air recovery device. I also want to point out that energy savings are more than capable with off-the-shelf systems that, when designed properly, can result in significant energy savings. The energy savings strategies for LEED newsletter and resulting broadcasts highlighted the capabilities of simple VAV systems using self-contained water-cooled unitaries in 5 different U.S. locations. This study was able to show which system and equipment energy conservation measures saved or didn't save energy costs in these different locations. If you'd like to get a copy today, ask your local coordinator or visit the Trane website. The CDS Support Center has seen an exponential increase in the support of LEED modeling. As Chris showed us earlier, the increasing number of LEED registered and certified buildings is resulting in a substantial increase in the use of whole building energy simulation software programs. As we've shown here, software programs are being revised and updated constantly to meet these new and changing requirements. Mick, there are some LEED Canada developments. Can you tell us about them?
Sure can. Scott, you know, while we've concentrated extensively on the U.S. changes today, the Canada Green Building Council staff, volunteers, TAG members, and many others have been working extremely hard to update a number of the LEED Canada documents to release in 2009 also. Our hearty congratulations to the crew and volunteers at the Canada Green Building Council. We were encouraged by Canada GBC representatives to share their successes since all 3 programs passed their ballots. The first finished was LEED Canada for Homes, with a March release of the reference guide. The second ballot approved was LEED Canada for existing buildings. Most recently, LEED Canada for New Construction version 2.0 was approved by Canada GBC members. Now, many of the LEED Canada credits are modified for Canada conditions, while others mirror those used in the US. One example of the latter is that the LEED Canada and the LEED US Enhanced Refrigerant Management Credit now use the same method. For LEED Canada homes, it's EA Credit 11. For existing buildings, EA Credit 5. While for new constructions, it's EA Credit 4. For those unfamiliar with this credit, here's a quick summary. If no refrigerant is used, the credit is achieved. If any refrigerant is used, this method balances refrigerant global warming and ozone depletion potentials as recommended by a technical scientific advisory committee. It's very important for those new to these calculations to understand that there is no refrigerant that receives a free pass. No matter the refrigerant, R134A, R123, R410A, etc., a calculation must be performed. If that calculation results in a score of 100 or less, the credit is earned. The balloted document gives some guidance for project teams by stating, quote, select HVAC and R equipment with reduced refrigerant charge and increased equipment life. The link to a spreadsheet that performs the calculations is given on the slide. Again, our sincere congratulations to the Canada GBC and volunteers who have worked on all the changes to update the products for homes, existing buildings, and new construction. Very well done. Jeannie, can you please summarize the broadcast for us?
Sure, Mick. Today, we presented in detail LEED 2009 changes specifically in HVAC with regard to energy, indoor environmental quality, water efficiency, and more. Chris gave us an overview of the evolution of USGBC's LEED products and changes in prerequisites. Mick gave us an update on LEED credits as they relate to HVAC and ASHRAE Standard 90.1 2007 and highlighted changes to the LEED accreditation program. Scott covered redistribution of LEED credits and provided information on the valuable features to look for when modeling for LEED. Now, we are all witness to the momentum LEED continues to gain, and with the new administration's green policy and the increased demand for energy efficiency, there's no doubt that this momentum will keep going. This quote from Michelle Moore validates the importance of LEED for all building owners, designers, and organizations. With USGBC's new focus on developing LEED rating systems, we can expect that new versions of the LEED rating systems will strive for accuracy, relevancy, and ease of use, and push for the innovative technologies and even higher performance. As Scott mentioned, there are a number of publications available that provide more information on the material covered today. And Mick recently published an Engineers Newsletter addressing the LEED 2009 changes. A bibliography detailing these resources is available from your local site coordinator. Past broadcasts are available on tape or DVD depending on the vintage, so please check out the website for more information on specific broadcasts. And we thank you all in advance for filling out an evaluation form before you leave. AIA members, please remember to turn in your member information to your local site coordinator. Now, we're hosting 2 more Engineers Newsletter live broadcasts this year, and many Trane offices will be hosting the ASHRAE webcast in April. In May, we'll be back with a design of a